Hey, welcome back. This is Tammy and I do math for coffee. And what we're going to be doing today is a review for your second semester geometry final exam. And it's dense, guys. There's a lot of stuff here. I've got 21 topics and I'm going to do 34 problems. Look down in the description and I'll put some timestamps down there so you can skip around. We're looking at a quadrilateral. The sum of the angles in a quadrilateral is 360, which means all these angles that you're looking at right now are going to add up to 360, including this corner, which is 90 degrees. So that's what I'm going to do. Start by adding those all up, setting them equal to 360, combining all those constants and doing some algebra, and we get x equal to 3. So you're going to probably need to pause. I'm going to go as fast as I can to keep this video as short as possible. We know that the diagonals are going to bisect each other. Then we know we have congruent pieces, which means we can set Qj and Js equal to each other. So 2x minus 2 equals 4 plus x. Do some algebra. And we get x equal to 6, which feels like you're done, but be careful in geometry. You did get the right x, but you're not done. They want to know what Qj is. So we're going to take that x and input it into the Qj. That's my dog bell. Excuse me. All right, substituting x in, we end up with Qj equal to 10, and that is the final correct answer. All right, we got a rhombus. It means all four sides are the same. And if you look at that with the diagonal, it really looks like two triangles sitting on top of each other, which is how I want you to approach this. You've got two isosceles triangles, and if you have isosceles triangles, that means we have base angles are congruent as well. So these two sides are the same, means that these two angles are the same. Well, the only angle we've got isn't one of those, it's 110. So what I'm going to do is I'm going to subtract that 110 from 180, and we're left with 70. And since the 70 has to be evenly distributed between these two base angles, splitting that in half gives us the 35. These two triangles are congruent, which means the 7x plus 7 equals 35. And there's our little algebra problem to solve. Here we go. Ta-da! X equals 4. State if the triangles in each pair are similar. Also, if so, state how you know that they are similar. These are the kinds of questions that makes everybody's brain freeze up a little bit. Here's how I would start. Eliminate choices. I'm looking at this picture. I don't have any sides at all. No information about sides. These little red things, these little red triangles mean that these two lines are parallel. It does not mean they are the same length. So since I know nothing about sides, I can eliminate C and D as options because that's not going to happen. So we are left with either these triangles are not similar or they're similar by angle-angle similarity. So this parallel must have something to do with it. I already know that these two angles in the middle are congruent because those are vertical angles. That's a gimme. All right, there's the parallel lines and we have a transversal. That should look familiar from first semester. That means we have alternate interior angles. So we have angle-angle similarity. They're telling us that the triangles are similar. So to start this, we have to set up a proportion, but I'm going to start by using the similarity statement to set that up. The similarity statement is these letters, which are the vertices of the triangles, and they're telling you what goes with what. T goes with D, U goes with E, and V goes with F. You can use these to set up your proportion. If you've never seen this before, watch. T and U are going to go with D and E. That means 70 and 10 correspond to each other. So I'm going to set up the first ratio, 70 over 10. Now to set up the second ratio, using the letters VT, that has to go with F and D. There we set up the rest of it. The 84 has to be on top because the 70 is on top and they are from the same triangle. The 2x plus 2 has to be on the bottom because it goes with the same triangle that the 10 is on. This is your proportion. Now you cross multiply. 70 times 2x plus 2 equals 10 times 84. And we do algebra. X equals 5. Pause and copy if you need to. If you're taking notes, which I hope you are. We've got two similar triangles, so we need to set up a proportion. Anytime you see the word similar in geometry, you're going to set up one of those proportions again. There's your big triangle. There's your little triangle. 3 corresponds to the same side as the x plus 5, so I'm putting those on top of each other. And since I led off with the 3, I've got to lead with the 7, and the 7 goes with the 28. They are corresponding sides. Now we cross multiply and do algebra. And we got x equal to 7. We aren't supposed to plug anything in. The directions say solve for x. I always double check that in a geometry class. And off we go. These are not similar triangles. What you have is one triangle and an angle bisector. You know that this is an angle bisector by these two little congruent marks for angles. So we're going to set up our proportion. Here's a little tidbit that you're supposed to know.
The angle bisector of a triangle bisects the opposite sides so that the ratio of the two line segments is proportional to the ratio of the two other sides.
Okay, that's the rule. What that means is everything is set up to be proportional. So how the 12 relates to the 15 is going to be the same as how the x plus 1 relates to the 5. These two are going to go together, and those two are going to go together. And here's the proportion. X plus 1 over 5 equals 12 over 15. You may see it differently, and you may set it up differently, and your teachers know that. So we all read the next line, because no matter how you set up your proportion, if you did it correctly, when you cross multiply, everyone should have 15 times x plus 1 equals 5 times 12. Algebra. X is 3. We're solving for x. And again, we've got some stuff going on here. These are parallel, and we're setting up proportional parts here. I see two similar triangles. There's a big triangle. There's a little mini-me. Since these two lines are parallel, we know these two angles are the same. And there's another pair of them. On this little triangle, we have the x plus 2. We need this side. I have a 12. I need that one. It's got to be 4. That's the reason the 8 is in the problem. You're not going to use the 8 as part of the setup. It's just that you needed to know that 8 in order to figure out that this was a 4. The 4 corresponds to the 12. There we go. So we're setting up the other proportion. So that means the x plus 2, which is this little chunk right here, has to go with this whole thing. And that whole thing is going to be x plus 12. X plus 2 plus 10 more is x plus 12. Cross multiplying, distributive property, algebra. Here we go. I'm going through this fast. This should be pretty familiar with the algebra. Again, you can always pause it. And if you have any questions about any step in a problem, put them down below. Ooh, look at this. We have midsegment. How do you know that's a midsegment? You've got this Q is splitting this whole side into two congruent parts, and R is splitting this whole side into two congruent parts. So that's called a midsegment. So we're going to write an equation. Midsegments are half as big as the length of the side it's parallel to. So 2 times the x plus 20. If I double the x plus 20, it's supposed to be equal to the x plus 32 side. Do the algebra, solve for x. And we get x equals -8. And then you're like, whoa, Tammy, that can't be a negative number. This is geometry. Let's plug it in and see what happens. If I turn this x into a -8 and add to 20, you get a 12. If I turn this one into the same -8, you get a 24. And look, 12 is half as big as 24. And if you wanted to make them equal, you would have to double the 12, which is what we did to set this whole thing up. You take the little one and take it times 2, set it equal to the big one. State if the three numbers can be the measures of the sides of a triangle. This is the triangle inequality theorem. And what that means is any side of a triangle must be shorter than the sum of the other two sides. I'm going to do some checking here. So if 6 is smaller than 12 plus 4, we're good. If 12 is smaller than 6 plus 4, we're good. And if 4 is smaller than 6 plus 12, any side of the triangle must be shorter than the other two sides added together. So this one works, and that one works, but the one in the middle does not work. 12 is not smaller than 6 plus 4. The answer here is no. You cannot make a triangle with this. No. Order the angles in each triangle from smallest to largest. This is actually one of the easiest problems you're going to have on your geometry final. Look at the sides. The smallest angle is going to be across from the shortest side. The shortest side, there's actually two shortest sides. There's 15. This is an isosceles triangle, which means these base angles are equal. We're going to order from smallest to largest. So that side goes with the N angle. So angle N is small, but there's another one, this one, an L. You could actually switch them because they're the same size. We don't know what the size is, but we just know their N and L are going to be the same. And then is across from M, so that's going to be the largest. So this is the correct order for these angles. Now in this one, we're doing the exact same thing, but we are ordering it the other way. Order the sides in each triangle from shortest to longest. I've got it all filled out here. I'm just going to explain it. 32 is the smallest angle. So the side across from the 32 has to be the shortest side. QS is the shortest side. 71 is smaller than 77, so 71 is in the middle. And that means this is the medium size. SR would come next. And 77 is the biggest angle, so this is the longest side. Find the missing side lengths. Leave your answers as radicals in the simplest form. Okay, kids, you need special right triangles. This is getting serious now. Start with a triangle that has a number, and then you're going to find the shared sides. Here's the only triangle that has a side length, and it's 7 and a 60-degree angle. This is what you're going to have to remember. This is the 30, 60, 90 triangle, and these are the proportions. The shortest side is across from the 30-degree angle, and that would be your base number A. The hypotenuse would be double that, and the other leg would be that number times the square root of 3. So here's 7. That is our base number A. That's what we'll start with. That means this side, which is across from the 90-degree angle, which is your hypotenuse, that is going to be 14. You're going to double it. I don't need to know what's going on down here, which would be 7 times the square root of 3. Not necessary. I need this one because this side is sharing the one that has the X on it. We're trying to move across. Now we have a 45-degree angle here, which means that's 45. We have a 45, 45, 90 triangle. We already know that the hypotenuse is 14. That means its base is A. The other side would also be A. And the hypotenuse is A times the square root of 2. Here's X. That means the other side is also X, because those are the legs, which means the 14 is the X times square root of 2. Just walk through it slowly. We set up an equation. X times the square root of 2 equals 14. Doing algebra, I'm dividing both sides by the square root of 2, so I would stop right here. No, I wouldn't. I want the answers as radicals in simplest form. 14 over square root of 2 is in simplest form. However, it's just a math grammar thing. You can't have a square root in the bottom of a fraction, so we're going to rationalize the denominator, taking the top and the bottom times the square root of 2. You end up with 7 square root 2. How you do your answer really depends on your teacher, it depends on the directions. It may even depend on the format of your test. If you have a free response question, your teacher might take 14 over square root of 2 and not be too concerned if you rationalize your denominator. But if this is a multiple choice test, you get 14 over square root of 2 and you look, it's not there, and then all the answers don't have fractions. This is how you're going to get to the 7 root 2. Find the value of each trigonomic ratio. This is an easy problem, but you have to know your trig ratios. This is SOHCAHTOA, kids. Yay! I love right triangle trig. We've got 5 questions coming up now with right triangle trig. They usually start with something simple like this, where you're just showing that you know what everything means. The sine of C, well, you are at C, you are standing right here, and this is your hypotenuse because it's across from the 90-degree angle. This right triangle is turned upside down. When you're standing at the angle that they give you, pretend you put your arms around the triangle. You're going to be touching the hypotenuse and the adjacent side. You are not going to be able to touch the opposite side. The sine is going to be opposite over hypotenuse, so that is going to be the 5 over the 13. Cosine is adjacent over hypotenuse, so that is going to be 12 over 13. Tangent is opposite over adjacent, which is going to be 5 over 12. That's all there is to it. You're not supposed to do anything more. Usually my students get a problem like this wrong because they keep working it. But no, this is not that kind of problem. There's one of those coming. We're supposed to find the missing side, this X down here. And we're going to round our answer to the nearest tenth, which is nice. No radicals. We're going to go for a decimal. All right, 66 is the angle that you're given. We have to figure out what we're going to be using here. Are we going to be using sine, cosine, or tangent? There we go. I filled in all my parts. I'm standing right here at the 66. That means the X is my adjacent side. The 15 is the only number they give me. That's my opposite side. I am not playing with the hypotenuse at all in this problem. I need to use opposite and adjacent, so I am using the tangent. We set it up. Tangent of 66 degrees equals 15 over X. I jumped ahead here. This is my next move. For algebra, I'm going to multiply both sides times x. I'm going to cancel out this fraction, and I end up with x times the tangent of 66 degrees equals 15. I like touching my calculator one time, so I'm going to divide both sides by the tangent of 66, so x is all by itself. Then I would grab my calculator and do 15 divided by the tangent of 66 degrees. I don't know which calculator you're going to use. You're going to make sure you know how to enter that, whether you have to use parentheses or any of that. But I ended up with 6.7. It said to the nearest tenth, which is 1 decimal point. 6.7. Find the measure of the indicated angle to the nearest degree. You are looking for this angle up in the corner. There's the 90 degrees, so you're standing up here. So you have to figure out which one you're going to use. You're here. That means the 22 is adjacent and the 54 is your hypotenuse. That means the A and H. You're going to be using cosine for this. The cosine of our unknown angle, happy face angle, is 22 over 54. On your calculator, the function that gets you that is the inverse cosine, the backwards cosine. Usually you would put an angle here where the happy face is, but we don't know what the angle is, so we have to work a little backwards. So you use the inverse cosine of 22 divided by 54. What you're really asking your calculator to do is you're going, hey calculator, I have an angle whose cosine is 22 divided by 54. What's the angle? And you enter it like this, it's going to say 66 degrees. Ta-da! We're done with that problem. We're still on right triangle trig. We're going to find the length of the side that's labeled x. Unlike that other problem, we got to start on the triangle where you actually have a couple pieces of information. I know this side length, I have an angle here, and I know that this is a right triangle, so I can use one of the trig ratios. We're going to start with the triangle that has a number, and we are going to find the shared side. That is this blue dotted one in between. We have to find that piece, and then we'll be able to repeat and set up a new trig situation so that we can solve for x. So starting over here, we're on this triangle first. We have the 24 degrees, so this is the opposite side to the 24 degrees. The 7 is the adjacent side, so I'm working with adjacent and opposite. That is tangent. So setting this up, we have the tangent of 24 degrees equals x over, well, I shouldn't have called it x, guys. It's not the same x. It's the unknown side over here, which is the opposite side. So stick with me. This x is going to be in context. So 24 degrees equals the opposite side over the adjacent side. So the side we are looking for is going to be 7 times the tangent of 24 degrees. And that turns out to be 3.1166. So now I know how long this side is. Switching over to the other triangle, we're going to solve for the actual x we wanted to solve for. 49 degrees is the angle that we have. We know the 3.1166 is our opposite side to this angle as well. This is also the adjacent side, so we're going to use tangent again. Tangent of 49 this time equals opposite over adjacent. That's how this sets up. Multiplying both sides by x and then dividing by the tangent of 49 degrees. I'm doing this fast, so this video isn't forever long, except I'm taking too long on this problem. Okay, we've got it, 2.71, and we are out of here. Find the area of a regular polygon. Yeah, this is a trig question. There is a formula for doing this. It's a pretty simple formula. It's area equals 1/2 AP, where A stands for something called the apothem, and P is the perimeter. Perimeter is the distance around, so that means we're going to need to find a side length so that we can add them all up. It's regular polygon, which means all the sides are the same. As soon as we find one, we know all 6 of them. This little piece right here where the 16 is, that's the apothem. The apothem starts in the center. It's like a radius, but instead of going to a corner, it goes to a midpoint of a side and makes a 90-degree angle. Okay, simple little formula, not a simple problem because you don't know how long the side is. We can figure out what a side length is if we draw this, and now we have a right triangle. We're going to be able to use trig eventually to be able to find half of a side, and then we'll be able to double it for the whole side. Got to do a little prep work here. You can find this angle that's in the center. Let's get started. Divide this thing up into little triangles. There are 6 triangles inside of a hexagon. Going all the way around once would get us 360. We are dividing it up into 6 pieces, so that means each one of those angles is 60 degrees. The one we want to use right here has to be 30 because it's half of 60. Now we have all the pieces we need to be able to start trying to solve for the side. The side piece that we want is opposite of the 30-degree angle. Piece right here with the 16, the apothem, in this case is actually the adjacent side to the 30-degree angle. So we're still going to use tangent. Tangent of 30 degrees equals opposite over adjacent. We don't know the opposite side, we know the adjacent is 16. Doing the math, we're going to take 16 times the tangent of 30, and wow, computer, thank you. You went really fast. So we get the x, the half of the side is 9.24. I want the entire side, so I'm going to double that. So an entire side length is 18.48. Now to get the perimeter, we have to take that one side length times 6, because this thing has 6 sides, and we end up with 110.88. Now we can use this cute little formula, because we know the apothem and we know the perimeter. So the area of this whole figure, this hexagon, is going to be 1/2 times 16 times 110.88. In my calculator, I just did half of 16, which is 8. 8 times this turned out to be 887.04. You're probably going to need to rewatch this one again and pause it. Find the measure of the arc or the central angle indicated. Assume that lines appear to be diameters are actual diameters. Remember, when you're starting something like this, the whole circle is 360 degrees. So that means half of it is 180. You're looking for this arc, right here, down here, the x plus 85, which means we have to figure out what x is first. Assuming things that look like diameters are actual diameters, that would be this guy. So that means all of these together are going to add up to 180. So that's how we start. Let's do that. Now, x plus x is 2x, 62, 53, and 85 are 200. Set that equal to 180. Algebra! And we get x equals -10. You'd think you're done. You're not. We want to actually know what this is, so we have to put the -10 with the 85, and our actual answer is 75 degrees. We are finding an inscribed angle here, measure of RQS. RQS, which means we are looking for this guy. Inscribed angles. I guess you have to see that it's an inscribed angle, which means you have to remember some stuff about inscribed angles. There it is. That's the angle. Inscribed means it's on the circle. A central angle is on the center. This one is on the circle. The thing you need to remember is that arcs are twice as big as their inscribed angles. So this 9x plus 5 has a measurement that is smaller than the 20x minus 7. They are not equal to each other. That's true for central angles, but not for inscribed. To set these things equal to each other to solve, you're going to have to double the 9x plus 5. I always tell everyone just double the smaller one because the math is a little easier. Distribute the 2 through. 18x plus 10 equals 20x minus 10. Algebra. We get x equal to 10. And you feel like you accomplished something because you have, but you're not done. That's like stopping before the end of the race. I need to actually know what the angle is, and we know that x is 10. So we need to pop that in there. And 9 times 10 plus 5, the actual answer is 95 degrees. I can see I do have a right triangle, that's why I colored that in, but the x is over here. But the thing is this is the same as this one, because you have a diameter cutting a chord, which means it bisects the chord. Let's say you forget that. That's okay. Just look at it. It's pretty symmetrical. If a diameter is perpendicular to a chord, it bisects it. Just trust your instincts here a little bit, guys. It's geometry. Everything is supposed to work out nicely. It's very symmetrical. So yeah, the x that we're looking for is going to be the same as that one. And we also have a little right triangle here because it's perpendicular. So we're going to use Pythagorean theorem. We have x squared plus 5.8 squared equals 10.9 squared. And watch me go through all the math really, really fast. 5.8 squared, 10.9 squared, that's the hypotenuse. Did the math, get some ugly looking decimals, and then we end up with x equals the square root of 85.17, which is approximately 9.2. I put approximately because I rounded that. We're going to solve for x, and it's way over here. We have intersecting chords, making intercepted arcs and angles. If your chords are intersecting inside of the circle, the way you find the 115 is you would have taken the arc 11 plus 12x plus 135 and divided it by 2. This angle right here is basically an average of its intercepted arcs. add them together, divide by 2, you'd get the answer, which is 115. We are looking for this x. So set up an equation, and that's what I did. I took the answer and I set it equal to the 11 plus 12x intercepted arc plus the 135 arc and divided by 2. I'm multiplying both sides by 2 right away just to get rid of that fraction. It'll cancel out the 2 on this side. 2 times 115 is 230, and the numerator just comes down. Cleaning that up a bit by adding the 11 and the 135, we get 146. Algebra. Subtract the 146 from both sides, and you get 84 equals 12x. Divide both sides by 12, and we get x equals 7, and we're done with that one. For this one, it looks the same as the last one because you have 2 chords intersecting inside of a circle, but this time it's a little different because they're not talking about angles or arcs. They're asking us to find the x, which is a segment length right here. If 2 chords intersect, the product of the pieces of one equals the product of the pieces of the other. We're going to set up an equation. Once you see it, you'll get it. I'm going to take the 18 times the x and I'm going to set it equal to the 27 times the 14. Once you've got that, just solve the equation. We don't have to plug this back into anything because it just said solve for x. Find the length of the arc. We need to set up a proportion to do this. This is the formula. It's arc length over the circumference of the circle equals a central angle over 360. So the arc length we're looking for is x. The circumference formula is 2 times pi times r, if you didn't know that. If I took 2 times pi times 12, the radius is 12. 135 is the central angle, and 360 is, in the formula, basically the comparison of the central angle to the whole circle is proportional to this part of the circumference to the whole circumference. Once you have this set up, we cross multiply. I'm not multiplying the pi through on purpose because I don't know if your directions are going to say in terms of pi, but if it does, you don't multiply the pi through. And we end up with this. Now, in terms of pi, your answer would be 3240 pi over 360, but you'd have to reduce those numbers to lowest terms, and you would leave the pi in the numerator. If you're allowed to keep going, you multiply the numerator times 3240 times pi, and then divide that answer by 360, you get 28.26 inches. Find the area of the sector. This sets up kind of the same way. We're going to set up a proportion. You have a very similar formula for this. It's going to be the sector area. A sector just means part of the circle here. If it was a pizza, this would be the part that I would try to eat, and I would leave the rest for my husband. So sector area over the area of the entire circle equals central angle over 360. There's the area of a circle formula, and there's the setup. The area over the area of this whole entire circle. The radius is 9, so that's 9 squared. And then it's 195 over 360. Once it's set, do your cross multiplication, and we do the algebra. There it is. And I'm not going in terms of pi, inches squared, because it is area. Find the segment length indicated. Assume that lines that appear to be tangent are tangent, which would be the line that's down here that has the question mark on it. That looks like it's a tangent line. Remember, a tangent line touches a circle at only one point and keeps going. And we are supposed to find what? That length right there. Okay, well, we know some stuff here. A tangent line will make a right angle with the radius where they touch. So right here, that's a right angle. That's 90 degrees, so we have a right triangle, which means we get to use Pythagorean theorem, which is this. We'll make the question mark that we're looking for our A. Our B is going to be this diameter. They only told us what one of the radiuses is, but we can assume the other radius is the same size because that's how radiuses work. The whole thing is going to be 14.4. When I go in to set up my Pythagorean theorem, a squared plus 14.4 squared plus 18 squared. Now I'm going to square those numbers. No, I didn't. What did I do here? Oh, I subtracted the 14.4 squared first. And so A ends up being, I actually did this whole thing in a calculator. Square root of 8 squared minus 14.4 squared. And depending on your calculator, you can too. It really makes life easier if you don't do all these little calculations in between. I just do it all at one time. And I ended up with A equals the square root of 116.64. So A is approximately equal to 10.8. And that's all we needed to find. So for x, assume that lines that appear to be tangent are, which would be these guys making this little birthday hat cone looking thing on the top. These are tangent lines. We are trying to solve for x, and x is up here in this little angle where these two tangent lines intersect at point D. And the way you look at this, these two tangent lines touch the circle right here, and that 130 is talking about this arc on the circle. Between the two places, the angle we need to find is up here. In order to be able to find that x, we've got to deal with that angle. So there is a formula for this one too. An outside angle like this is going to be the big arc minus the little arc divided by 2. And you're probably going, Tammy, there's only one arc. No, there's this one too. You got to find the other arc. That's how you start. That's your big arc. If you take 360 and subtract the one that you know, you end up with 230. This isn't a formula you're going to find in a textbook. The one in the textbook that you look up, or the one on your formula sheet that you look up, is going to be like this one. I've just translated it into English. So big arc minus little arc divided by 2 equals the outside angle, which they're telling us is 8x minus 6. I did the math. 230 minus 130 is 100 divided by 2 is 50. Algebra. I added 6 to both sides to get 56, so now we have x equals 7. We got to solve for x again. Something's happening on the outside here, but we aren't talking about angles. We are talking about segment lengths. Once again, here's a formula that is me translating theorems into English. I called this the ow. Outside times whole thing equals outside times whole thing. Let me explain that to you so you'll remember it. We're going to set up an equation and solve. Outside times whole thing. Outside times whole thing. Outside times whole thing. The 9 is not multiplied times the x, but the whole thing, which is 9 plus x. That equals the 8 times the whole thing, which is 8 plus 19. Ow. I did distributive property. 9 times 9 is 81. 9 times x is 9x. And then this is 8 times 27. I just added the 8 and the 19 together. I subtracted 81 from that. I still have to do 8 times 27. Algebra gets us to x equals 15. We got another ow here, but this one's a little different. Sometimes you have this situation happening where you don't have a secant that's shooting through the circle on both sides. Sometimes you have a tangent. So here's how you set that up. You still use outside times whole thing, outside times whole thing. It's just that the outside and the whole thing are the same number. For this one, it's 9 is on the outside and 9 plus x is the whole thing. So that's the equation. That's how you start. Once you have that, solve for x. Find the surface area. What you're doing when you're finding a surface area is you are looking for the exact amount of wrapping paper you need to wrap that sucker with no overlaps, which means you have to recognize the shapes you have that make up this cylinder. And we're going to use all these formulas at some point in this problem, because what you have is you have a circle here at the base on the bottom, but you have the exact same size circle on the top. So you actually have 2 of those. So I'm going to start out by finding the area of a circle that has a radius of 4, but doubling it because I have 2 of them. The area of a circle is pi r squared. So pi times the radius squared. The radius is 4. 8 is the diameter, so the radius is half of that. That's 4. I have 2 of those circles. I do the math. I get 2 times 16 pi, and that's 32 pi. And if you want to put that into a decimal, there it is, 100.5 meters squared. We got to set that aside for a second. That part's done. The part we need to figure out now is the wraparound part. Remember, if you wrap something around a circle, that's called the circumference. If this were a can and I peeled that off, you would have a rectangle. The side length of that label would be the circumference, which is pi times diameter. So it's 8 pi going from here to here. The height of that label is the height of the cylinder, which is 10 meters. The area of a rectangle is length times width, so that's going to be 10 times 8 pi, which is 80 pi, which is 251.3. That's area, so that would be meters squared. I forgot to write the units. We have the area of the 2 circles, and we have the area of the label that goes around this thing. So the only thing that's left to do is to add them together to give you the total surface area same cylinder with the same dimensions, but now we're asked to find the volume. Volume is how much stuff you can put in there. So how to start this is to find the area of the base, and you're going to multiply it times the height. That's basically the big idea for finding the volume of anything. You find the area of the base and multiply times how tall it is. A visual for that, well, there's a circle area formula. I'm going to need that in a second. A visual for that is if you were taking all those circles and stacking them up on top of each other, it'd be the area of the base times the 10 meters. That would be the entire volume. You are trying to fill this thing. A lot of people think of it as filling it with water. Personally, I kind of like to think of it as a stack of Pringles. The volume is going to be the area of the circle, which is pi times 4 meters squared times 10, which is the height. This turns out to be 16 times 10 times pi. That's 160 pi, and that works out to be 502.7 meters cubed. Find the volume. Same thing, area of the base times the height. But this one's a little tricky because this thing isn't sitting on top of its base, it's laying down. The base of this is the triangle on the end. The bases are the same shape, and then they connect with these other rectangle pieces. So there's my base. I'm going to be filling it up with a bunch of those triangles. So I find the area of that, and I'm going to multiply it times 12. The area of this first base down here, the height is 4, the base is 3, it's 3 times 4, 1/2 is in the formula, so that's 6, and then I'm going to multiply that times 12. And we end up with, yeah, we don't need the 5 at all. That's in there to throw you off. As soon as you figure out something's in the diagram that you don't need, cross it off. So the volume is 6 times 12, and that is 72, and our unit is cubic because volume is 3-dimensional. So yards cubed. Finding the volume of a cone, there's a little tweak we have to make to it because it's pointy. So area of base times the height. So it's the same thing. We'd find the area of this circle times the height, which is 7. But that would be if it were a cylinder. And then you end up having to divide it by 3 because it's pointy. Again, I'm not using formal language. I'm trying to explain this in a way so that you can get this right on your test. Anything, a pyramid, a cone, anything like that is like the basic formula for volume, and you have to divide it by 3. And I'm going to try to explain why. If this were a cylinder and I put the cone inside the cylinder, you have a lot of empty space in here, right? Well, look, 1, 2, 3. The part that is the cone is only 1 out of 3 possible parts. 1 out of 3, 1/3. That's where the divide by 3 comes from. So find the circle area, pi times r squared, multiply that times the height. That would be like if you were finding the volume of the whole cylinder, the whole can, but then divide by 3 because it's pointy and you're not using all the space in there. And we end up with 28 pi over 3, which as a decimal is 29.3 centimeters cubed. Remember the units is cubed because it's this a 3-dimensional figure. Last problem finally. I included this one because this usually shows up on somebody's final somewhere. A word problem with no picture. A cone has a volume of 120 cubic inches. The height is 4 times the radius. Find the radius to the nearest tenth. Do not skip this problem. I'm going to show you how to do it. First off, you do not have a diagram. So the first thing I want you to do is to draw a cone or borrow one. In this case, we're borrowing one. If this is your actual test, it's on paper. The problem we just did is a cone, right? I don't want all the numbers because I'm going to change that stuff up. So I'm going to scratch out all those numbers. I'm just going to, and I would be doing this on the test on this problem. I didn't draw on it before. I'm just doing the work on this one. Okay, and I crossed off this little radius because it says I only need one radius. I don't need a diameter. All right, now I'm going to fill in some information. The volume is 120 cubic inches. That's the answer. That's what we're going to set our volume formula equal to. V stands for volume formula. Height is 4 times the radius. So the radius is the smaller thing, and the height is 4 times that. So I'm going to make the radius r, and I'm going to write 4r for my height. That's all I can do right now. You don't know what the numbers are. The only thing you got is the 120. So we're going to write the formula for volume, which is pi r squared h divided by 3. That's the actual formula. And r is our radius. We already have that squared, but the height, instead of writing an h, I'm going to write a 4r. You could have done this with x's too, and maybe that would have been a better way to go about it for you if you're confused right now, but I'm pretty lazy and I knew radius is r and the other one is 4r. Made sense to me at the time. Okay, so this is what I've got. The answer 120 equals pi times 4r cubed, r squared times r is r cubed, divided by 3. I need a little more room to solve this equation. Scoot that up there. Okay, I'm going to multiply both sides by 3. I did that in my head. 120 times 3 is 360, and the reason I did that was to clear this fraction. The pi 4r cubed just comes down. I am going to divide both sides by 4 pi right now. I'm doing this in my calculator. You're going to check it on your own. 360 divided by 4 pi is 28.65. And those things cancel on this side. You're just left with the r cubed. In order to find the radius, you need to take the cube root of 28.65, which you are not doing any of that in your head. I came up with the radius of 3.1 inches. You guys, as I record this, I have no idea how long this is going to be when I edit, but this was a heck of a video to put together. I would appreciate the support. Could you please put a like on this sucker so people can see it, especially if you think this kind of stuff is helpful. If you want to look at the rest of the geometry videos, they are in this playlist. If you'd like to look at the first semester study guide, I'll put a link there too. Thank you so much. I appreciate you. Bye.